Problem 1, a company having a cost of capital rate 8%, so that is interest, purchase a $300,000 loader. This machine has an expected service life of 4 years and will be used 2,500 hours per year. The tires on this machine cost $45,000. The estimated service values at the end of 4 years is $50,000. Calculate the hourly depreciation portion of the ownership cost for this machine using the time value of money method. And then we calculate the hourly ownership depreciation using the average investment method. So with that one here, as you can see, for the depreciation portions, that either part A or part B of this problem askings, we have two methods: the time value of money, something we learned in project planning and apply to here, and the average investment method, that you don't need to have a knowledge of the time value of money. And for the average investment method, we determine for the depreciation portion, the cost of the money portion itself, and the depreciation portion. So add them, we will have the depreciation of the ownership cost for this method. And as you can see here, for the first lesson videos of today's class, you have the operating costs, have the tire. So the tire, even you buy the machine, including the tire, but the tire should be subtracted from the owning costs. So with that one, what we do in here, we need to have the purchase price of the loader, and then we subtract the tire. So first thing first, we have the purchase price less tire. So tire is more with the operating cost, not the ownership or depreciation. If you learn the project planning, go to the depreciation lesson, I explain why that. So here it equal to original price 300,000 of the machine, of the loader, subtract the tire cost 45,000. So we have that is the 255,000. So with that one, part A, we need to calculate the hourly depreciation portion. So hourly, that is the keyword, of the ownership costs, and using the time value method, time value of money method. So with that one, we need to hourly. So it means that something that we talk in time value of money, we need to have the equivalent annuity A, because that hourly. So first we need to find out the what is the equivalent amount for this investment, $255,000. So the first thing we need to use, of course, this one they use the time value of money method. Time value of money method. So with that one, as you can see, we can be able to determine the equivalent annuity A, because they ask hourly, so you need to have the annual amount first, and then we have every year they use 2,500 hours per year, so we can divide that, we can find out the hourly depreciation portion of the ownership costs for this machine. So with that, we invest the let's draw the cash flow out. You have here years, so we put down at the beginning less the cost, 255,000, and at the end of year 4, 1, 2, 3, 4, because this service life of this machine is 4 years, you can resell this machine for 50,000. That is service values, 50,000. So with that one, as you can see, we can have the annual annuity. It means the equivalent amount of this spend 255,000 and receive 50,000 for the service values, like you sell the machine on Craigslist for 50,000. So it will be equal to 255,000. And annuity is 255 is the present value. So you will have that equation is given P/A. So we have a factor A over P with the interest 8%. The problem gives us for 4 years. And then we minus 50,000 because that's what we receive, time the factor that is happen in 4 years, and we want to have the equivalent amount every year, which is here. Equivalent amount. What is the equivalent amount every year for years? So that's what we want to find out. And that factors something in the future with the annual amount. So we have the factor given F/A, so A over F, 8% and 4. And with that one, we can go to the reference, the last page of the final exam reference. The factor given P/A, so we have I, 1 plus I power n over 1 plus I power n minus 1. And the second equation that we use is given F/A, so we have I, 1 plus I power n minus 1. So that you have it in here. I can plug in the first factor is equal to I. Go back here. You have A over Pi, 1 plus I power n. Here. So you have I, 1 plus I power n. So it will be power 4. So let's put power n, put first. And then we have 1 plus I power n minus 1. And then we have subtract 50,000. We have the next equation given F/A, I, 1 plus I power n minus 1. So you have that one here. I, 1 plus I power n minus 1. So you can plug in the number. So you have 255k. So I is 8%, so 0.08. 8% plus 1, so 108 power 4. That's 4 years. And then 1.08 power 4 minus 1. Minus, continue, 50,000. And then we have the factor will be 0.08, 0.108 power 4 minus 1. And from this one, you will get this number equal to 76,985 minus 11,095. So you will get that equal to 65,890. And this is the same amount every year. So that equivalent that we buy that equipment and get the service value of 50,000, it means that equivalent we spend $65,890 per year. And that then we can determine the hourly depreciation cost. Hourly, that is the question asked. Cost. So with that one, we have the 65,000 that we equivalent amount every year, and then we divide every year. This equipment operate 2,500 hours, so 2,500 hours per year. So with that one, we can have that is $26.36 per hour. So it means the depreciation cost for hourly it charged for this equipment is $26.36 per hour. And then now we can be able to use the simpler method, but it's not as accurate as the one we just did. That is the average investment method. So with the average investment method, we need to know what is the average investment, initial cost, plus service value divided by 2. So we have that is the average investment. It equal to initial cost 255 plus service values 50,000 divided by 2, so that you will get average investment. I call that AI equal to, let's name that AI average investment. So average investment here it equal to 152,500 per year. That is equation per year. That the average investment per year that you have. And then for that method, we need to find out the cost of money portion and depreciation portion and add them up. So here we can have the cost of money. So we have that is cost of money per years, it interest 8%. So you have 152,000 per year. Interest cost of money, it means that how much money we need to spend for the interest if we have that average investment. So 8%, that is the interest, the cost of capital for this company. And then per hours, every year they spend 2,500 operating hour for this machine per year. So with that we have 4.88 per hour. So that is the cost of money, the interest that you pay. And then the second portion for this method, the depreciation portion. And let me use the straight line method. Then we have the straight line, so 255 or initial divide minus 50,000 service values, straight line method, divide by the number of years, that is 4 years, and of course 1 year is 2,500 per hours per year, hours per year. So with that we can get is the $20.50 per hour. So $20.50 and then year cancel out, so the denominator become an hour, so you have $20.50 hours for depreciation portion. So with that, we can, with this average investment method, we can be able to find out the hourly depreciation cost. Hourly depreciation cost. We add them up. We have for the ownership cost, the cost of money that we, the cost of money, the interest, 488 plus the depreciation cost, 20.50 per hours. So with that, we get equal to $25.38 per hour. And that is the answer for the average investment method. The answer for the time value of money, the most accurate, 26. So as you can see, the two methods give you different answers. Two methods give you a different answer in here, but very close. So the most accurate for the depreciation cost is $26.36 per hour. But if we make a quick calculation without the knowledge of time value of money that you learn in project planning, we can determine that is $25.38 per hour, so it's about 1 hour less.